The topic of vector-borne diseases prevention, control, elimination, and eradication. I am Professor Dr. S. Sabesan, Senior Consultant from Indian Council of Medical Research Vector Control Research Center, Puducherry. So I am happy to share with you the topic with you. It is very simple and straightforward, and sometimes we may have a small confusion. Sometimes especially between terms like control, prevention, and also elimination and eradication. Sometimes eradication and extinction. This kind of the usage, where to use, how to use, whether we have any definition for this terminology, all these things will come into our mind often. So I take this opportunity to share with you these things. Actually, way back to 1993, there was an international task force on disease eradication, evaluated over 80 potential infectious disease candidates, and concluded that 6 were eradicable, and like mumps, polio, and one among the 6 is the LF, lymphatic filariasis. In 1997, World Health Assembly passed a resolution calling the member countries to adopt the strategy of going for elimination of lymphatic filariasis as a public health problem. Then, in the same year, 1997, in Berlin, there was a workshop conducted, and the experts have been discussing and debating on the several of the usage of these terms, on especially on the eradication of infectious disease. In the dialogue workshop, there were 4 questions mainly to address. That is, how to define the eradication, what are the biological criteria for this definition. The next one is the criteria for estimating the cost and benefits of the disease eradication. And third is the social and political criteria for this eradication. And the last one is when and how should eradication programs be implemented. So these are all some of the questions discussed, debated, and addressed. So accordingly, it was mainly focused on the infectious diseases. Though the infectious diseases are the communicable diseases, and the vector-borne diseases are also the communicable diseases category, and of course infectious. So by and large, there is an overlapping of these things, and we bother more about the vector-borne diseases, but still we may need to know what are all the diseases which were eradicated, and if eradicated, what are they? The only one infectious diseases, namely the smallpox, was eradicated in 1980, and that still stands as a landmark in the history of the control of infectious diseases in the world. The international community is now well down the path towards the eradication of poliomyelitis and also trachonitis, guinea-worm infection. We are almost nearing that eradication of both the polio and also the guinea worm. So we are very close to that, and we hope that we will shortly be able to declare that it is eradicated. Then the infection that results in clinical manifestation and also sometimes a subclinical stage. That is the control. Let us discuss first about the control of infectious diseases or control of the vector-borne diseases, which refers to the action and also the programs directed towards reducing the disease incidence, that is new infections. Here also there will be a confusion between the prevalence and also the incidence. If you closely look into these two things, then we will have the clarity. And the control, we can aim for control of anything, aiming at again anything. So we have to define the control. Here, first let us see what is the reduction in the incidence, that is new infection. The second thing is the reduction in prevalence, because it is already occurred. The prevalence is what is the existing load of the infection in the community at any given point. That is prevalence. Whereas the incidence is new infection. So I hope you understand both now the difference between the incidence and the prevalence. And you can have control over the first and as well at the second. Even we can say control of the third stage, that is even towards the eradication also we can tell that is a control. So on three different contexts, you can view this control. So control aimed at reducing the incidence, that is new infection of vector-borne diseases, or the risk factors can be considered as primary prevention. So here also you notice one more thing. Here we are using in the same slide control and as well the prevention. Now you have to carefully read the line. The control is aimed at reducing the incidence of PVD, or control is aiming at the risk factors. Ultimately, that means we are trying to prevent. That is primary prevention. Otherwise, what will happen if it is not there? That will end up in incidence. So now here, control is aiming at reducing the incidence. So that point is the primary prevention. So second thing is the primary prevention protects health through the individual and as well the community, including actions as immunizing agent against the infectious diseases, keeping the vector density below the threshold level, or the risk factors, anything you think of against the vector breeding itself. All these things will come under the primary prevention. So second is the secondary prevention. The control aimed at reducing the prevalence. The first slide, what we have seen is reducing the incidence. That is the primary prevention. Second, now we are telling about the we are discussing about the reduction in the prevalence. So the existing already cases are there, or the it is existing, it has come in. So here we are trying to reduce the prevalence. That is considered as secondary prevention of VBDs. And the secondary prevention corrects departures from good health, because the first one aimed at good health. That means we are not allowing the entry Here it has already entered in the disease. What we are trying to do here, we are trying to reduce the prevalence. So through individual and also community-wide measures, and including such actions as screening that result in early detection and treatment. Here, because already cases are there, here early detection and treatment will ensure further increase of cases. So that is a secondary prevention. And here ensuring the cure of affected ones, and also we are trying to protect the risk groups who are likely to get the potential risk groups. So here trying to do both. We are trying to detect, treat the cases, and also protecting the risk groups from picking up the infection. So this is the secondary prevention. And third is the tertiary prevention. What we are trying here, control aimed at reducing or even eliminating the long-term impairments of PVDs can be considered here as tertiary prevention. For example, in the case of filariasis, tertiary prevention reduces or eliminates disabilities, minimizes suffering, and promotes adjustment to permanent disability through such actions as providing MMDP. MMDP is nothing but morbidity management and disability prevention appliances and its associated rehabilitation of the victims, and by counseling, casual training, prevention of reinfections. Just I want to elaborate further. Morbidity management. Here again there will be a small confusion about the morbidity and also the disability. Morbidity, already the symptoms, signs and symptoms will be there, and we will be suffering from the infection. Whereas the disability, already each organ in our body is meant for some function. But if there is an impairment in that particular organ, then we may not be able to perform our duties, normal function of the organ. That is the disability. So if we are unable to perform, to see, unable to walk, so something disabled or some disability. So morbidity management and disability prevention. What we are doing, morbidity management, we are trying to give home-based morbidity management is being advocated. What we are trying to do, one side we are trying to keep the periodical fever, that is ADP, adenolymphitis related fever. We are trying to reduce the frequency of fever and also further deterioration of the edema, because it is we are trying to prevent the progression of the lymphedema cases. Otherwise, what will happen? The lymphedema will gradually from recent edema to persistent edema, then ultimately that will end up in elephantiasis. So now we are trying to prevent. So therefore it is called tertiary prevention. I hope now you will get a clear distinction between the primary prevention, secondary prevention, and also the tertiary prevention. The distinction between these three terminologies. And control perceive. Control, we have in all the three category in the previous slides, you have made control. Control of what? One is infection incidence. Second, the control of the prevalence. And the third, tertiary, also we have seen. There are three stages. Here, again, we want to reiterate what is control all about once again for a clear understanding purpose. The reduction of disease incidence, prevalence, morbidity, and or mortality to a locally acceptable level as a result of deliberate efforts. So all these things comprisingly, all control only. And continued intervention measures are required to maintain the reduction. Once we got a reduction means that is not an end. So for further progression of any of the things from incidence to prevalence to morbidity and also for morbidity, we do control. So unless otherwise you sustain the accomplishments or sustain the status which you reached by one control is not sustained, then it is very likely you will go to the next stage. Therefore, we have to maintain always the reduction achieved. Therefore, continued intervention measures are required. How we can control? Just a few examples. Just control measures include identifying and then reducing the vector abundance. We have to see where it is breeding, what are all the factors contributing to the vector abundance. If it is possible to eliminate that infection agents responsible at their source, the first one is the vector, the second one is about the parasites at their source and the reservoirs, animal reservoirs it could be. So the control is not only against the vector and also are reducing the vector abundance, but also we can aim at reducing the parasite load in the individuals and also at the community level. So both are the control. And the next thing is breaking or interfering with the routes of transmission of infectious agents. So this is interrupting the transmission, because there you may have opportunities or ways and means to cut the transmission at a different link, because these are all three major components are here: host, vector, and infectious agent. You know the life cycle and see where the link is weak. There we have to aim at interrupting the or cut the link, and we will be able to break the transmission. So that is all about. And identifying the susceptible population and then reducing or eliminating their vulnerability. Here I want to elaborate a little further. We used to ask vector-borne disease people, we are involved in the vector-borne disease control. We need to know two important things. One is related to the vector, and the second one is related to the human. The one is about the transmission facilitating factors. There are two aspects. One is about the vector, that is we used to tell as receptivity. Receptivity means where the vector is breeding. When if it is the breeding is proliferate in a high vector population, then the area or the focus is called the receptive. Or if it is abundant, then we used to tell it is highly receptive. And the second the term we used to tell about the population movement from one place to the another between endemic and non-endemic areas. That is called the area is vulnerable. If the foci or the site which attracts the population movement between endemic and non-endemic means that area is highly vulnerable. And if that area is happen to be highly receptive and also highly vulnerable, then we can say that the transmission is likely, provided that area environmentally, if it is conducive in terms of temperature, mainly temperature, relative humidity, you all will know about these things. The humidity and the temperature is favorable, and the area is happen to be highly receptive and vulnerable, then transmission is very likely. So that is all about. Then tools for control related interventions. Control measures applied to the human host is mainly, or we cannot say mainly, it will vary from disease to disease. For example, in the case of JE, Japanese encephalitis or brain fever, we have at least we are now able to protect our kids. For children, JE vaccination is now implemented across the country in endemic areas, selected endemic districts. It is already there, and we are now trying to prevent the JE. At least we are now able to protect the children. And hemoprophylaxis. This we are, we can say, we are able to protect population, especially for malaria. And hemoprophylaxis, to some extent, we can say the MDA also indirectly it is preventing the people from picking up the infection, hemoprophylaxis. And behavioral change. What is behavioral change? Because people have a tendency to not all are accepting either IRS or LLIN, and they may have barriers for they may used to tell about many things or not using. So the mindset we have to change, and that is all about the behavioral change and barriers, and improving sanitation. And this is mainly for suitable or more applicable to the dengue. If you can concentrate on this environmental sanitation, by and large, we will be able to substantially reduce the incidence of dengue. So that is possible. So the control measures applied to the human host, all these things, if we can really focus on these aspects, to a greater extent, we will be able to prevent the incidents. And control measures applied to vectors. You all know that there are three ways. One is the chemical, second is the environmental, and third is the biological control agents. So how we can make a chemical, either you go for fogging, again insecticide you are using. IRS, again you are using insecticide. Either LLIN, again you are using in chemical insecticides. So here you know if you go back to the history, we have been using the DDT in 1960s. Then we have switched over to the OP compound from OC to OP compound, organochlorine to organophosphorus compound. Then we have switched over to carbamates. Now we are using pyrethroids, synthetic pyrethroids like alpha cypermethrin and all. Where do we stand? There is no guarantee that we will not have any resistance, because when you are exposing the vector to the chemical insecticides, definitely only the duration varies. Otherwise, we will face the problem of resistance. And the best way is to use the environmental measures and also the biological measures. Environmental measures, you have two environmental measures like the environmental either manipulation or environmental management. I hope you may know what is the difference between the management and also manipulations. Environmental manipulations, all the transient kind of thing you may need to do repeatedly. Whereas in the case of management, you will have the permanent solution. You may need to spend more, but that will be a long-lasting solution for the as far as the environmental measures are concerned. But still, we may need to go a long way to address these measures, unless otherwise you have a strong the support of the local body or the resources. And the third one is the biological control methods. And you all know that people, especially in malaria and dengue, we used to go for fish, gambusia, and also for the guppy as biological control agents. And our center in VCRC, Puducherry, we have been recently trying to use the Wolbachia parasite in Aedes mosquito to prevent the dengue transmission. Still, it is at the laboratory level, we have got some encouraging results, but it is not that easy to take it to the field on a large scale, especially in a country like India. And so there are, but yes, it is there is a possibility for the biological countermeasures, but the worldwide or globally accepted thing is the means of fish is the best option, but in all occasions we may not be able to use the fish. Then the elimination of disease. This the terminology is, I hope you all will be very familiar with this use elimination, because now we are using elimination for at least 3 diseases right now. Waterborne diseases like malaria, hepatic filariasis, and also Kalasar. Of course, we go on change or extending the target period or target date from 2010 to 15 to 20. Now we have fixed the target date to 2030. Okay. Now, what is all about elimination? Here also, I see the difference. Reduction to zero of the incidence of a specified disease in a defined geographical area as a result of deliberate efforts. So here, the zero, pardon? So the elimination of a disease is one thing. The incidence of disease is also an elimination, and the continued intervention measures are required to move forward or to sustain. The next is also elimination, but now the elimination of infection. See the difference there, the elimination of disease, here the elimination of infection. This is what the MTA does in the case of filariasis. So reduction to zero of the incidence of infection caused by a specific agent in a defined geographical area. Now we have the geographical area, the unit of intervention is now we called as a district. We are planning to reduce the even this geographical area to a block level, but at the moment we have district as a unit, and we declare through tasks whether the area is task passed. That means what? The incidence of infection is brought down to zero, but in reality it is not zero. We are aiming below 1 MF. That means we continue to have the MF, and but below 1, below 2% of the antigenemia. Why we have not aimed at zero? Hope you all know that if you can continue to keep below 1 for a longer period, gradually that may not be able to sustain. I mean the parasites. The parasite may not be able to sustain for long, and as a result, in due course of time, we may be able to
proof
so here the objective is in the case of ideally it is zero, and in the case of yellow we have the leverage like below 1% MF, assuming that if you can keep the below 1% MF, we may be able to achieve the complete cutting of transmission or interrupting the transmission. That means the new case will not occur. So the reduction to zero You may ask, sir, reduction to 0 is elimination, but in the case of filariasis, reduction to below 1% of the incidence of infection is acceptable. Yes, it is acceptable because this is because of the simple reason that below that threshold level, transmission will not occur. So that is why we are called. But to be on the safer side for elimination, for the definition, we have to remember that 0 is the ideal thing, but we have fixed the threshold level as 0.1%. I hope you understand this point. And here again, continued measures to prevent re-establishment of transmission is required. Otherwise, what will happen? That is why we don't stop with the task 1. We are going for the task 2, task 3 and all, just to see whether there is any re-establishment of infection. Therefore, here we continue the measures. And eradication. Permanent reduction to 0 of the worldwide incidence of infection. So, in the previous slide for elimination, we have been telling about in a defined geographical area. Defined geographical area can be at the block level, the district level, or state level, or the country level. We can say it is eliminated in a particular foci. Whereas when we talk about eradication, it is always at the worldwide. So permanent reduction to 0 of the worldwide incidence of infection caused by specific agent as a result of deliberate force. And intervention measures are no longer needed. This is most important. In many of the previous slides, we were told that intervention continued to require. Whereas here, once a disease eradicated means 0 incidence at the world level achieved means no control measures is required. So eradication has been defined in various ways as extinction of the disease pathogen. And also elimination is achieved. And even in the absence of preventive measures, control measures, that the incidence will not occur. And as reduction of the worldwide incidence of the disease to 0 as a result of deliberate efforts, obviating the necessity for further control measures. Since we have achieving 0 at the world level, we are sure that it will not, there is no chance for the re-establishment of the infection of the disease. So eradication, it is a unique endpoint in the control of infectious disease is that of eradication. Endpoint in the control. There is no further control. And this is a cessation of all transmission or extermination of that agent. So there is no infection, parasite or pathogens in the whole world. Then we can call that is an eradication. Whether it is possible, anything is possible. We have some examples like smallpox. Now we are going for polio and also trichomoniasis. What we need a high level of sustained political will and a very strong administrative skill, aggressively applied surveillance and effective control measures. Then we will be able to achieve the eradication of VPDs. So nothing is impossible, but we need to go a long way to achieve this. And definitely let us hope that it is possible. And the extinction. The specific infectious agent is no longer exist in nature or in the laboratory. Example is none. The previous slide, we have been discussing about the eradication. Now we are telling extinction. What is the difference between extinction and eradication? The eradication, so no longer we are free from that infection. That means what? there is no chance for the re-establishment of the disease. Then that is finished. Then where is the question of extinction? I mean, the difference. Here, the specific infectious disease no longer exists in nature or in the laboratory. Smallpox is eradicated in the world, but still we have the virus in the laboratory. At least 2 laboratories are still have in US and the USSR laboratory. The vaccine, I mean, the virus is kept in the laboratory in a highly protected way. It is the international understanding. Therefore, we cannot say it's an extinct. Eradication has achieved, but extinction, no. So the specific infectious disease no longer exists in the nature and the laboratory means we can declare that it is a distinct species. But we do not know whether any vector-borne disease infectious agent is an extinct one. So example is none. Thank you.